Ready to harness the power of your communications data? Blast off with Nylas today.
Hi, Blag. How you doing today?
Hello, Ash. I'm doing fine, thanks.
So we're here to talk about another one of your programming concepts, and we're going to dive into logic programming today. So this will be another chance for me to sort of like totally sit in the learning seat. You gave me a little preview of what we're going to talk about today, and super interesting stuff. So I can't wait to dig in.
Cool. And just you guys remember, I'm not an expert in logic programming. I haven't done much of it, but I like to explore it and explain it the best way I can. So this is going to be just a small introduction to logic programming, and we're going to be taking a look at Prolog. So Prolog is a logic programming language that first appeared in 1972, so like 50 years ago. It's pretty old. It's widely used on artificial intelligence and also on computational linguistics. And as most of things lately, it can be installed by using brew. So one of the main aspects is that we have facts, rules, and queries. So a fact would be that I like caramel. A rule can be that if I like caramel, then I most likely eat caramel. And the query would be if I actually eat caramel, which is something funny because actually, for example, I like strawberries, but I don't like strawberry ice cream.
Okay.
But I do like strawberry ice cream that is made of yogurt, which is kind of funny, just kind of something funny to mention.
Well, at least you kept it simple then for us just getting started with logic programming by focusing on something that's pretty simple for us to keep in mind. So I'm looking forward to seeing how this factors in.
So actually, let's see an example of how that works. So here we have a little source code, and you're going to see that actually Prolog uses the same extension of Perl, so it uses PL. And this case is going to be ice cream.pl. So we're going to say here some facts. For example, that Blag likes caramel, Ash likes chocolate, and Ram likes vanilla. So the rule would be that if someone likes a flavor, that someone most likely eats a flavor. So we're going to say that eats is going to be a likes. So, for example, Blag likes caramel, then it means that Blag eats caramel. It's kind of like we're making here an assumption, but we also linking the likes to the eats.
Yeah, it's interesting that they come in like what would be like, at least in terms of English language, like backwards order.
Yes, exactly. So to execute it, we just do sweep L, which is the most used Prolog interpreter. We type here ice cream. We need to finish always with a period. And it's going to say true because it loaded the program. So here we can say, for example, it's Blag caramel. It should say true because according to the rule, I must eat caramel. We can ask if I like caramel. Again, true. And what if we want to know what that Ram likes? I can say likes Ram, and here an X. So, sorry. This is going to return that likes Ram likes vanilla.
Why is that happening? Can you talk us through that? So this is something when you showed it to me earlier, I was like, wait a second, what? This is not something I'm familiar with. What's the X? And
So
how did your program know that instead of just making a random call, you were actually, I guess, making a query?
Yeah. So pretty much X here, it's a variable. We use capital or uppercase letter for the variables. So we're saying here that Ram likes something, but we don't know what. So we say like likes Ram, and here we put an X. So whatever the result is gonna be inside that X. So as we said here, that Ram likes vanilla. When we ask that question, likes Ram, then vanilla is gonna be tied to this variable and it's going to be returned to us.
Okay, and does it know that it's a variable because it's in all caps? Because I might have,
Yes.
you could almost like, for example, replace X with like, I don't know, Apple. And would it accidentally assume that that was a variable, or because it's in all caps, it knows?
Because it's an uppercase.
Okay.
Yeah.
Very interesting.
Yeah. It's kind of weird the first time you see it. So let's continue. So obviously recursion is also very important, just like in functional programming it was pretty important. Recursion allows us to call the same function multiple times, and Prolog relies a lot of list. So it has variables, it has list, doesn't have arrays or anything like that. So we have some ways of handling them very easily. And as I said, Prolog doesn't have loop contracts, so we need to use recursion. So let's
kind of reminds me of your when we were talking about functional programming a week or two ago. Similar concept there.
Yes, exactly. So here we have a couple of comments saying that H stands for head, which is the first element of the list, and T stands for tail, which is the rest of the list. So here we're going to pass a parameter, a list, and this means that if the list is empty, the program is going to stop. Otherwise, if we have some elements on the list, it's going to say, okay, I want the head, which is the first element, and I want the tail, which is everything of the rest. So what we're going to do, let's say on our list we have 1, 2, 3. So this one is going to say, okay, print the first element, 1, then do a carriage return, so leave a space, and then call list again, but passing the rest of the list. So it's going to print 1, and here it's going to pass 2 and 3. It's going to say, is the list empty? No. Then grab the head and the tail. Print 2, and then call list again, but passing 3. When it passes 3, it's going to say, is the list empty? No. It's going to grab the header, it's going to write 3, and it's going to call the list again, but now we don't have any more elements. So it's going to say, the list is empty, we're done.
So it's slowly printing the first element in the list and removing it essentially. Yes. And then it effectively what I guess I would expect to see if you're passing 1, 2, 3 is that in a list we're going to see 1, 2, 3 printed in order. Is that right?
Yes. So let's see here an example. I'm just calling recursion between brackets with a period at the end to load the file. And here I'm calling the list function, and I'm passing a simple list 1, 2, 3. When I press enter, it's going to print 1, 2, and 3.
Okay, wow. I have to say, like, based on when I got the preview earlier of this, looking at that script at the beginning in Prolog for just a moment was a real head scratcher. But yeah. I think like getting to see it in practice like this makes a lot of sense. Really interesting.
Yeah, and you can pass obviously not only numbers, but you can pass strings, and it's going to be exactly the same.
So can I, in terms of Prolog, that on line 3, you have it highlighted in the script there.
Yeah.
So I guess like that's like the base case, if you will, like what it gets the recursion to stop.
Exactly.
And so how does Prolog know that that's the base case? Is it because it's just the first line of the code, or what's going on there that where Prolog knows, okay, hey, there's nothing else to do?
Because it's going to say is the function list is receiving an empty parameter. You're not doing anything. You're just putting a period. So you're not printing, you're not calling anything. It's just stopping.
Oh, so this is kind of like an overloaded function then, and that if you call it with a list, then it's going to know to go down to line 4 and execute that code. But if you call it with an empty list, then it's going to handle line 3, which essentially does nothing.
Exactly.
Right. Cool.
Yeah. So let's keep moving. So also, variables are immutable, just like in functional programming. So once a value is assigned, we cannot change the value, but we also have unification. So unification means equality. So a variable needs to have the same value in order to be unified. This kind of weird, but you're gonna see, because this is important because it allows us to keep track of variables and their relationships. So if I quickly share my screen, if I say, for example, 3 equals 3, they unify because they're the same value, right? If I said 4 equals 5, it's going to be false, obviously, because they are not unifying. And you might not think that this is important, but let's look.
I'm assuming it's important because it has a special name, right? Unification is not something I feel like I hear in any other context. So while
Yeah,
what you just laid out in terms of the numbers is kind of obvious on its surface, my guess is this becomes pretty important because they've gone through the trouble of like giving the concept its own special name.
Yes, exactly. So this one, in this example, for example, we have this path, right? So we have that 1 leads to 2, but it also leads to 6 and to 3 and to 4. 4 leads to 5, 5 leads to 6, but also 2 leads to 6. So we can make a programming prologue where we can ask like how to go from 1 to 6 or for 4 to 6. And it's going to show kind of like, it's going to return kind of like the shortest path. But we can also print all possible paths. And we're going to see that in the example. So we just need to remember that there's a relation between all these numbers. So if I share my screen, and I go here we are defining the connection between the nodes. So we're going to say, we're going to call it edge to call it something. So 1, 2, or 1 is connected to 2, 2 is connected to 3, 2 is connected to 4, 2 to 6, 4 to 3, and so on. So we're going to receive the start and end points. So for example, we want to start on 1 and we're going to go through 6. And we want to reach the end point. So we're going to get, for example, 1, we're going to get 6. And here, we're going to return kind of like the path. So what we're going to do essentially is we want to go from 1 to 6. It's going to say, okay, I'm going to start on 1. And I need to find a 2 because that's kind of like the connection. So it's going to say like 2, 3. No, because I need 6. 2, 4. No, I need 6. 2, 6. That's the one that I need to go to. So it's going to be recursing until it finds the right one. So we're going to load it, and you're going to see it better when I run it. So here, I'm going to call path. I'm going to say 1 to 6. And then here, I'm going to pass a variable path. So it's going to contain the shortest way.
And just to reiterate, this is just like earlier when you used that X variable, which was basically in that situation a way to query what someone liked. In this case, you're passing in what I presume is an empty variable, and you're going to get that back with some value assigned to it.
Exactly. So if I go 1, 6, it's going to say that shortest path is going to be 1, 2, and 6. And we can look here, 1, 2, 6. Obviously, we can go like 1, 2, 4, 5, 6, but instead we're getting 1, 2, 6. And here's something funny, or actually nice. Here I put this exclamation mark, which is like a hard stop. Like it's like when you reach this, don't do anything else, just stop. But I can comment that out, and I can actually recall the path, and you're gonna see the difference. So I'm gonna call the same function again. Now you see it's different because it didn't stop. It said 1 to 6. And if I put a semicolon, it's gonna also give me 1, 2, 4, 5, 6, which is kind of like the longest path.
Yeah, that's interesting. So, okay, that's not what I was expecting. I assumed that when it didn't stop, that was because it was in some sort of infinite loop. But instead what happened is it kind of takes a pause, I suppose, until you hit enter, and then you can get the next value. I mean, you're still like, I assume, were you after that second return where you get the longer path, did the script automatically exit at any point, or did you have to kill it?
No, it's gonna be a stop when it reaches a false conclusion. Like it can not go anywhere else.
Okay.
So you see, it's gonna always go to the shortest path, and then if it can, it's gonna go to the longest path. So for example, if I say 1, 4, I think it was 1, 2, 4. There's one that should give us like the longest one. So for example, 1, 2, 3, or 1, 2, 4. Let's say we want to go. Let's say one. Well, you give us 1, 2, 6. So you get the idea. I'm not sure if we can do anything else here that might explain better.
I don't think your node layout is complex enough to sort of go off the rails like that.
Yeah, so basically you get the idea.
Can we have a look at the script one more time? I just want to, for clarity here, and again, if anyone's watching, and it's like, what's going on here? Certainly, it took me a couple of looks to start to even like let it soak in. But I think like just from lines 1 through 8, where you have all of those what appear to be edge calls or edge functions, is edge a specific, like a special keyword in Prolog, or is this like a name
No,
you made up?
It's just the way that I call each of the numbers, so like each of the connections.
Got it.
You could say here whatever, like I don't know, spin or something like corner probably. So here we said when we hit this point, it's because we reach the end point, right? So for example, we start from 1 to 6. So it's gonna go like start on 1, grabs 2, so it's a connection. It's gonna go 2, 3, no, 2, 4, no, 2, 6. That's what I want. But if we haven't reached the end point, which is in this case, like we're going 1, 2, and then we're reading 2, 3, which is fine because 2 is connected with 2, but it's not 6, so we haven't reached it. It's simply going to look for the next path. So here, we're going to use C as a new variable to actually look for this connection. So it's just going to go looking, okay, 1, 2, then it's going to say, now I need to go to 2, 3, but it's not the one that I need, so it's going to go to 2, 4, it's not the one that I need. So when it reaches 2, 6, it should stop. In this case, when I had the hard stop, for me it was like, once you reach your goal, just stop it. I mean, I don't need like you to continue to keep looking for other alternatives.
Okay, really cool.
You can just like go and go and go and go and go.
Well, awesome. Is there anything else you want to talk to us about logic programming today?
No, I think that kind of the basics that you need to know in order to learn Prolog. It's not that easy most of the times. Probably let me see if I can quickly share a more complex example, just so that you get a better idea of what you can do with this. There's a nice example that I always like to use. Here. This one is kind of more complicated. So let me share it. So this one is kind of like one of my favorite examples of all time. It's kind of like you pass 1 to 3 and it's going to return it like in LED format. So here I have like all the numbers from 0 to 9. And here is the way you made them, right? So
Sure.
that thing, yeah, you can look that's right. You're gonna see what I mean. Um, Here, for example, I'm saying like you're gonna get the digits, and you're gonna if you have 1, 2, 3, you want to have the 1, then the 2, then the 3 on a list, and then you want to make something. I haven't done this in a while, but you're gonna see this is kind of like a more complex example. So ideally, when you run this, it's gonna be something like this. So if you call 1977, it's gonna show it like this.
Okay.
2017 is gonna show it like this.
All right.
Yeah.
Okay, so that helps explain what some of those hieroglyphics were in that first sort of thing, which makes sense. Okay, cool. So I'm not even going to try to start picking that apart for the purposes of this live stream, but maybe that you can share a link on social or on YouTube or something for people to check that one out. So just before we close out, is there any sort of practical use for this in our daily lives, or is this like one of those things that
Well, it's actually pretty using artificial intelligence. I haven't used it for that, but the fact that you can like use facts and queries and everything, it makes it really good to actually make the computer think. So there are some pretty awesome use cases. Just look for it on the web. But there's also Visual Prolog, which should be kind of like the next step, kind of like probably simpler to use than the regular Prolog.
Oh, so there's various. That was another question I was hoping to get to. Do you think Prolog or its alternative there is like those are some of the good ones to get started with, or are there other languages out there that you would recommend?
I think Prolog is the most used one. It's like the most common when you talk about logic programming. There are a couple more, but Prolog is like the king of logic programming.
Okay. Cool. All right, Blag. Well, once again, thanks for breaking my brain in front of the world. This was actually pretty fun because I feel like on the second pass through for myself, I had a few unlocks based on your examples, which is really awesome. So thanks for introducing a really cool concept. And for folks out there watching, sometimes if you watch the live stream a lot, most of the time we talk about Nylas and how to work with email contacts and calendars through our APIs, but sometimes we like to just dive into the weeds of some different programming concepts. And if you liked this one, there's another video out there that Blag and I did, or really, Blag taught me and everyone else about functional programming not too long ago. So that's worth checking out on our YouTube channel. And as a matter of fact, we can throw up a link to the YouTube channel in case you're watching this somewhere else.
Next week, stack-oriented programming is coming. That's even more weird.
Great.
And actually, Ash, you on Friday are going to be the host, so I'm going to be the one asking questions.
That's right. Yeah, for the first time, maybe the first time ever. Yeah.
That's awesome. Looking forward for it.
Okay, well, so check out Coding with Nylas on YouTube. Lots of really cool stuff in there, and we do a couple of these live streams a week, so content is growing quickly. Thanks, Blag, for walking us through logic programming and Prolog today.
Sure, my pleasure. Hope you liked it.
All right, bye, everybody.
Bye, see you. Take care.